FPGA architecture, it is mainly consisting of three important components. So what are the important components it is consisting of? It consisting of an IO blocks, it consisting of an logic blocks, and it consisting of a programmable interconnect. Okay, so we will study these components in details one by one. Okay, the first one. So what do you mean by logic blocks? A logic block, it is nothing but it is a combination of multiplexers along with a Boolean expressions simplifications. It is the combination of the multiplexers along with the gate arrays. We call it as a logic blocks. So these logic blocks are responsible for the implementation of the any Boolean expressions or any programming. If you want to do it, then by using these logic blocks, we can able to create the programmable components. Okay, then what are the components of these logic blocks is? So generally logic blocks will be pulled by a pull-up transistor and a pull-down network. Along with that, it will be having a multiplexers and it will be having a switching devices. And for the multiplexers, so we will be using a select lines. So the type of select lines we are going to use, so based upon that the input will be fed and we can able to implement the logic expressions. So therefore the logical blocks are responsible for us to do the implementation of any Boolean expressions. That is, we call it as a logic blocks. The next one we call it as a programmable interconnects. So what do you mean by programmable interconnects? So we have a logic blocks, as I said you, a smaller component programmable blocks we have. And now if I want to have a communication from one logic block to another logic blocks, we need to do the interconnection. So the interconnection of one logic block to another logic block can be done in a programming manner. So how it can be done? It is responsible for the programmable interconnect unit. A programmable interconnect unit, it is responsible for interfacing of one logic. Just wait a minute. Programmable interconnect logic, it is responsible for interconnecting the one logic blocks into another logic blocks wherever the subsystem need a communication from one logic block to another logic block for the implementation of any certain applications. So that is responsible for that are the functionalities of the programmable interconnect. The next one is IO blocks. So what are the functionalities of the IO block? IO blocks, it is responsible for feeding the input for each logic blocks and the programmable interconnects. So what are the resources which are required for the implementation of any Boolean expressions? So that will be driven by the input and output blocks. So one simple example what we can give you. So if I want to implement a full adder means, then I need a 3 input blocks and two output blocks I need. So what are the 3 input blocks? A 3-bit input signal we need, that is nothing but A, B, C, and the corresponding 2 output pins we need, that is nothing but sum and carry. So the IO block, it is responsible for us to do the interfacing of the input terminal and output terminal for the logic blocks. See, the logic blocks is operation is to do to solve the given simplification expression, or it is used to implement the given Boolean expression. But for that we need to give the input section. So that input section will be given by the IO blocks. So you can see here the IO block also, it is having a 2 subsection. One is we call it as a pull-up transistor, that is a pull-up network, and one more we call it as a pull-down network. So if you want to go for the logic highs mechanism means, then we go for the pull-up network. If you want to go for the logic low mechanism means, then we go for the pull-down network. So this is the internal architecture of your FPGA. Okay, so it's not only you are going to do the programming for the logic blocks, you can do the programming for the IO blocks also, and you can do the interconnection of logic blocks into that is IO blocks through programming. So that is responsible for the programmable interconnect logic. Okay, so we go for the next one. Okay. So now you can see here the FPGA architecture, how internally it will look like. So you can see here the logic blocks or the CLB, that is nothing but a programmable, that is a clocked logic block slices we have, and this clocked logic block slices, they have been interconnected through the use of programmable connections. And what are these CLB slices, that is a programmable logic blocks? So you can see here it is a implementation of certain table. So that table we call it as a LUT table. So what do you mean by LUT? LUT we call it as a lookup table. So then what is the difference between truth table and lookup table, you can ask me. So in truth table what we do is we will find the relation of input and output, and based upon the relation of input and output we will be generating the truth table. Thus in the same manner, for each logic block or for each component in the architecture of your FPGA, we will be creating the table which represents the what is the input and what is the output of that block, and how the input and output blocks are mapping with respect to the output terminal. So in order to see the representation or the relation of input and output at a particular block, we will be using a LUT tables. So this LUT table will give me the same information what we have done in the truth table, but the LUT table, it is responsible to realize, or it is responsible for us to know what are the relations of input and output at the particular block. Okay, so that we call it as a LUT. So at each instant of time for each logic blocks, so we are going to create a LUT tables. Okay, so based upon the number of LUT tables what we have generated, so based upon that we can able to see the performance and speed of the FPGA component, we can able to measure. And your logic blocks, it's not only we are going to do the arithmetic or boolean expressions, so sometimes it is necessary for us to do the storage of the information. So in order to do the storage of the information for the FPGA architecture, we will be using the flip-flops, and based upon the flip-flops we can able to store the output of particular sections in these registers. Okay, so your FPGA, it is not only it is responsible for the implementation of the combination circuits, it is also responsible for us to store the registered network or a sequential circuits. So this is how your internal architecture. So in the previous diagram, so we have categorized the FPGA architecture into three important functional units, that is a programmable interconnects, logic blocks and IO blocks. Whereas in the case of this diagram, so how the interfacing or how actually the logic blocks will look like, and what are the entities of the logic blocks are highlighted in this slide. So you can see here for each LUT table, that is for each logic block, you have input sections and you have output section. To represent the input and output sections, we have created a LUT table. So LUT table is nothing but a lookup table we will be having. And if you want to store any combinational circuit or a sequential circuit, means then we will be using a registered logic, that is a flip-flops we will be using in order to store the some subsystem output over these devices. And in order to the controlling of this logical circuit and the storage mechanism, two bus lines will be overflowing on top of the CLBs. So one we call it as a data bus and one we call it as a control bus. So the data bus, it is responsible for the movement of the data from one subsystem to another subsystem, whereas your control blocks, it is responsible for which operations has to be executed first and what are the terminal we need to consider. All those things will be responsible will be included. The information of the controlling information will be included in the control bus. So these are the internal resource of FPGA kit consisting of matrix of configurable logic blocks, that we call it as a CLBs, so which are surrounded by the peripheral IO blocks. So the signals are routed within the FPGA matrix by programmable interconnect switches and wire routers. So we are going to do the programming on the IO blocks, and also it is possible for us to do the programming on the signals where the signals will reaches the IO block and also the configurable logic blocks. So these also can be programmed with the use of the interconnected switches and the wiring routes. So this is the internal architecture of your FPGA. Okay. So now a detailed analysis as I explained, so which will be given in this architecture. So what do you mean by logic blocks? So logic block of an FPGA can be configured in a such a way that it can provide functionalities as simple that of the transistor or a complex as that of a microprocessor. So logic blocks are responsible for the implementation of the Boolean expression, and also it is responsible for us to provide a complex solutions. So whatever we have the functionalities which can be done by a single transistor to a microprocessor, what are the functionalities which will be done? So all those functionalities can be implemented through the use of this logic blocks, and it can be used to implement different combinations of combinational and sequential logic functions. So it is responsible for us to implement the different combinations of the combinational circuits also we can able to implement, and sequential logic function can also we can able to implement through the use of this logic blocks. Okay, and these logic blocks of a filled programmable gate array can be implemented in a different combinations or in a different manner. So the first manner what we can make a use is n input lookup tables. So we can make use of this through the use of n input lookup tables. We can do the implementation of the logic blocks, or we can go for the multiplexers, or we can go for the implementation of the flip-flops, or we can go for the implementation of the buffers. So means what? So these logic blocks are responsible for us to implement the following elements. So what are the elements we can able to implement? We can able to implement the lookup table, we can able to implement the multiplexers, we can able to implement flip-flops and the buffers. Okay. So these are the functionalities which can be implemented, or these are the elements which can be implemented through the use of the logic blocks. The next one is internal interconnects. Okay. So what are the responsibilities of interconnects? So routing in FPGA consisting of wire segments of varying lengths which can be interconnected via electrically programmable switches. So now you have one logic block you have and one more logic block you have, and you want to do the connectivity from one logic block to another logic blocks. So how it has to be done? It has to be done with a wiring segment through the use of a routing table, or through the use of the routing mechanism. We should be able to connect the one logic blocks to another logic block. So depending upon the subsystem, or depending upon the logic elements where they have placed in the FPGA, so based upon that it is necessary for us to do the routing of the signaling or wiring of the segments has to be taken care. And the density of the logic blocks used in the FPGA depends upon the length and the number of wire segments used for routing. Okay, so how many number of components you have used for the logic implementation, so that also plays an important role for the interconnects. So why? Because if you are using a millions of devices, or if you are using a millions of transistor over single segment means, then in order to energize or in order to power such a system, the wiring has to be very thin in such a way that there should not be any interconnect should establish, or the short circuit should establish in a high million device density logic blocks. In such a cases also, this interconnect plays an important role in order to identify or in order to do the excitation for the each elements of the logic blocks. And the number of segments used for interconnection, typically it is a trade-off between the density of the logic blocks which are used and the amount of area used for the routing. So you have to make a trade-off. So what is the miniature size I want to create for my chip, and how many number of elements I can do the implementation of the logic blocks on a given miniature size. So you have to make a trade-off. So if you want to go for a very compact device means, then the routing information has to be very accurate. So for that you need to establish a very complex circuitry or a complex routing mechanism. So if you want to go for a very simple routing mechanism, so then you need to reduce, or you need to reduce the density of the logic blocks which you are going to implement over a certain miniature component or a circuit chips. Okay, so therefore it is necessary for us to make you to have a trade-off between your logic blocks, the number of logic blocks what you are going to use for the implementation, and the amount of area you are going to cover for the routing. So more the density of the logic blocks, the area covered by the routing will be more. If the less of the logic blocks implementation if you use means, then the area covered through the use of routing it will be minimum. So you need to make a trade-off. So what based upon the trade-off, you can able to decide the density of the logic blocks and the amount of area which is used for the routing mechanism. Okay, so you can see here, this is how the simplified FPGA architecture will look like. So in the center part of the architecture of your FPGA, we have a logic blocks, and at the terminals, so we have a IO blocks, that is the input output sections we have, and here also at the terminal at the right corner you have a IO input output blocks you have, and the placements or routing information will be taken care in the bottom and top approach of your architecture, whereas your logic blocks, programmable logic blocks, will be placed at the center of your architecture. So you can see here the interfacing or a connection of these IO blocks will be through your programmable logic blocks will be done through the use of interconnects. So it's not only we can do the programming for the IO block, we can able to program your interconnects also, so that if the program has to be changed means, then it is necessary, or we can able to change the program not only for the logic blocks, also we can change the program for the interconnects also. So this is the internal architecture of the FPGA, how it will look like. The structural classifications, so based upon how the implementation you are going to do, go for the logic elements and the programmable interconnects, and how you are going to place the memory. So based upon that, so we can do the classification for the FPGA structures. Okay, so these structures are mainly depends upon the arrangement of the logic elements and the programmable interconnects on a based upon a particular manufacturers. Okay, so based upon the manufacturers, so the placement and routing of these programmable logic elements and the memory the placement, so based upon that we have a different classifications of the FPGA. Okay, and these classifications, that is the internal arrangement of these logic blocks and programmable interconnects and the memory, so which we are going to divide into three important classes. So first we call it as a symmetric arrays, and the second classification we call it as a row based architecture, and the third we call it as a hierarchical PLDs. So we can able to implement your FPGA based upon these three classes. One we call it as a symmetrical array, row based architecture, and a hierarchical PLDs. Okay. So the first one is your FPGA symmetrical array. So this is the diagram of your FPGA symmetrical array. So this architecture, it consisting of a logic elements. So as we already called that, it is a programmable logic arrays. It is consisting of a row of arrow column and matrix, and which has been interconnections has been laid between them. Okay, in this architecture, that is in a symmetric matrix, the interconnects, the outer part of the interconnects has been surrounded by the IO blocks. Okay, so these IO blocks we are going to use in order to do the interconnection to the outside ports. Okay, and by the use of these IO blocks also we can able to control the functionalities not only which is related to state control, we can able to control the speed of execution of the certain operations. Okay, so we are going to feed the input section through the use of IO blocks only. It's not that is a fundamental functionalities of the IO block. Along with that, it is possible for us to do the controlling mechanisms through the use of the IO block. And each logic blocks, as I said you, it is consisting of an n input lookup table and a pair of programmable flip-flops it will be having. And the interconnects, as we know, it is a routing path. So if there is a direct connection between the logic elements means, then the delay will incurred by such a mechanism will be less. If you want to do the logic connections, that is interconnection of one logic connection to another logic connection, if they are far apart means, then the delay will be introduced. So how you are going to take care of this delay, it will depends upon the implementation or the programming of the interconnects, how you are going to do it. Okay, so this is one of the example of your symmetrical array FPGA implementation.